So let's continue talking about bit depth. What happens though when you sample, right? It takes a sampling of the voltage of the signal at that time, and then it tries to apply it to the closest bit. Now, as you can tell, it's not always going to line up exactly on a bit. It's going to be between bits. But if you've got more bits, then it's more likely you're going to be closer to an actual bit, like where a number is assigned. So the computer then takes and assigns that voltage to the closest bit. That's called quantization error. Okay? So when it's quantizing this, it's taking its samples and it's saying, okay, it's closest to this bit. It's not exactly that bit, but it's closest to that one, closest to this one, and so on. So you end up with some inaccuracies, right? So the result, added noise, is equal to half the amplitude of a bit, which makes sense because if it's halfway between a bit, the error, the most an error can be is half of a bit. But those little sampling, those little bit depth assignment errors create quantization noise and errors. The quantization error can look something like this. It actually has a regular pattern to it, and having a regular pattern means that our ears can pick up on it and hear it and understand what it is. So the quantization error combined with the signal looks something like this. This is the actual results on a 15-bit system. So you see that there is some noise being generated by errors, and it's kind of regular, so we should be able to actually detect it and hear it. So this concept that digital audio is perfect audio isn't necessarily true. It would be perfect if we had an infinite bit depth and an infinite sample rate, but then we're back to analog. So the problem with quantization error is that it's a periodic kind of a noise, and it's picked up by the brain. This noise floor can be hidden by the use of sound masking. Remember when we talked about what masking was? When you've got one frequency and you've got perhaps white noise. Oh, we did talk about it, I think. When you walk into a doctor's office and they've got the wave machine in the waiting room, it's creating this white noise so that you can't hear anything that's going on elsewhere because it's masking it and blanketing it over so you can't make a definitional determination of other sounds coming through the walls or the doors. Even the best converters will have digital quantization error. The better converters convert it more accurately, but built into the system itself is a quantization error. It has to be, because you only have so many divisions on the vertical axis of bit depth. And the voltage sometimes at the sampling time will fall in between two bits. And when that happens, what does the computer do? Say, oh, we just can't take this one. No, it says, okay, I'm going to assign it to the closest one. So the most error you can have is a half of a bit depth, half of a bit division. And it assigns a digital number to it. Yes, it's a noise floor that exists due to erroring in digital sampling, in digital conversion. Okay? But you can mask it so that you don't notice it by randomizing it. The only way that we understand it as noise is because we can hear some sort of a regular pattern in it, and so we can identify it. If there was no regular pattern, then it would just be like this noise floor that exists in our daily lives. If everybody's very silent and listens to the ambient noise of a room, there's a noise floor going on. We don't recognize it, we ignore it. Our brain sort of ignores it because we're used to it, and we don't consider it useful information. So we sort of discard it. And that's what masking can do to this quantization error. So masking is done very effectively to eliminate this quantization error noise by the use of dither, which is noise that's injected with an amplitude equal to just over half the distance between the possible values of the quantization error. This randomizes the error and keeps it from being periodic, and then our brain doesn't hear it in that way. Okay, so we were talking briefly about how our digital systems work, and what we're working with is PCM systems, which are pulse code modulation. The analog waveform is broken into pulses, and the voltage is measured and assigned a number. That's how it's digitized, right? So the direct streaming digital system, also known as delta modulation, is a different kind of a process that we don't use right now. And actually, in answer to your question, could there be a different way of coding analog signals into digital? And there is. The way that this works is it's a bit streaming kind of a system where when the voltage goes higher, you get a more dense stream of ones and zeros. It's streaming along. It's writing zeros and ones, zeros and ones, zeros and ones. And when the voltage gets higher, you get more ones concentrated into one area of the stream. When the voltage goes down, you get more zeros, right? So it's about concentrations of ones and zeros, not actual numbers assigned to bits. You get this streaming of ones and zeros that represent the voltages in an analog signal, and it's pretty much more accurate. So here you go. Common sample rates, which we discuss, 44.1 kilohertz, 48, audio and film and TV standard sample rates, and then the high definition sample rates. And then the DDS system, or I'm sorry, the DSD system is the streaming kind of a system. And look at the sample rate of that. Look at the rates at which ones and zeros are created. At 2.8 megahertz, much, much faster. So the potential of having concentrations of ones and zeros is far greater, and it represents the voltage rises and fallings of an analog signal. It's a really interesting way of thinking of it. Rather than just breaking that signal into chunks and assigning numbers to it, it basically, the concentrations of the ones and zeros represent the voltage peaks and valleys. Now that said, let's talk about the differences between analog and the digital recording processes. This is something that I kind of enjoy because there is pluses and minuses in both. Can anybody give me a plus part of analog recording, why it's good? The tape medium compresses. If used in a certain way, you get a compression on the tape medium and it makes it sound better. Number two, tape is extremely durable. It's long lasting. As long as you don't put it in a magnetic field, it'll last for 50, 75, 100 years, right? So long lasting and durable. Okay, what's a negative about analog tape? So these are positives. What are negatives? Yeah, you don't get much recording time on a piece of tape and it's costly. Number two, there's a noise floor. There's always going to be a tape noise floor involved. And the dynamic range isn't as great as digital recording. Okay, so let's look at the flip side of what that means for digital recording. Digital recording. Let's look at the pluses first. Depending on how much memory and how much processing power you have in your computer, the system's virtually endless, right? So more tracks and editable, much easier than analog tape, and undoable, as we all like to use the undo function, right? What's a second plus about digital recording? Less expensive. One hard drive can hold 10 albums for $100 when one piece of tape is 15 minutes of recording for $300, and it's only 24 tracks. Okay, let's look at a negative about digital recording. Quantization errors and sample rates have to be converted from one to the next to be compatible. So compatibilities, not only compatibility of the audio files, but also compatibilities of DAWs, right? Digital audio workstations, right? So if I get a session from somebody that's in Logic, but I want to bring it up in Pro Tools, it's going to take me a lot of work to deal with it. And this is another thing. In the old analog days, you take your tape to another studio, and you put it on the tape machine and play it. Somebody brings me a file on a hard drive, I'm like, okay, first off, was this done in a PC or a Mac? Second off, what bit depth is it, and what sample rate is it? Third off, what version of Pro Tools did you use? Was it 10, 12, 7? I've got a Pro Tools 7. 7.2, I've got 8, I've got 10. What version is it so I can convert it to the system I'm going to use? Was it HD or was it not? All those kinds of things. Very important. It's not as easy as just like bringing your hard drive to a new studio and say, here you go. Well, do they have the same plugins as I have? Right? So it's a little more difficult to be compatible with other people. Number 2, a negative. Storage, though it's cheaper, it's definitely more delicate. Drop your hard drive, oops, I just lost 10 albums. I had a hard drive go bad on me one day. I walk in the studio, everything's going great, and I wasn't a big fan of backing up at that time. And I turn on the computer, and I get this big question mark blinking. Oh no, what do I do with this? I'm really handy with a screwdriver, but what am I going to do with this blinking question mark on my computer screen? Had to bring it into the shop, and they had to replace the hard drive, and I lost everything on it. And I took the hard drive, sent it to a data reclaiming center that could have charged me, $8,000 for it. And this is back in the day when you couldn't go on YouTube and find out how to do it. Couldn't get any data off of it because the arm inside had actually landed on the spinning disc and lathed off all of the magnetic material on my hard drive. So it could never be reclaimed, ever. And I lost 3 albums. I had to re-record them.
Really?
It took me 3 months. Yeah, and I had to do it for free because they'd already paid for it. And then I had to convince them that the new version was better than the old version. That was the hard part. So let me tell you, you don't want to be in that position. Never. So back up, back up, back up. So anyway, there's pluses and there's minuses about both formats, and it's wise to know both. When somebody walks in a room and says, analog sounds so great, it's so cool, it's so vintage, because they see my 2-inch tape machine in the corner that's got dust on it, and they want to record an analog because it sounds so great, I'm like, yeah, but do you want to fix vocals and stuff? Do you want to time correct drums? Do you want to do any of those things that everyone wants to do? It's going to be really difficult on analog. So I try to use a hybrid version of both. If somebody's dead set on having that analog sound, like I said, I'll mix to it and then bounce back. That works really well to get that analog compression tape sound. So there's pluses and minuses of both.